Welcome, listener. This is Louis, host of The Cove, the podcast where we go deep with crypto builders along the path to 100 million daily signers. What would it look like if today you remade the EVM from the ground up with a focus on performance and speed? What kind of TPS can the EVM do when pushed to the limit? How might the EVM still constrain you? Why is composability so exciting? All that and a few more spicy takes at the end are coming up right now as I interview Kevin G in Developer Relations at Monad. Let's do it. All right, so I'm here today with Kevin G from Monad in the Developer Relations area, and we're going to chat all things about supercharging the EVM. Welcome, Kevin.
Nice to be here. Second time's a charm.
Yeah. Okay, so let's kick things off, and I guess Monad is like relatively newish or newish to some of the listeners. So could you like lay out sort of the basics of Monad?
Yeah. Monad is fundamentally like best way to put this at like maybe 10,000 foot view is like the classical like embedded or high performance computing like optimization version of an EVM. Okay, so what does that mean like from kind of like top line things or innovations? That's like pipelining and parallelizing the EVM and also like making the database backend very efficient. So the things we're doing are essentially things that have been like best practices in high performance computing systems for, over 20 years now. So what really attracted me to Monad is that like it's not kind of open research in the sense of like we don't know if these things are possible. Like they're very possible. And so that really excited me with the approach Monad was taking to an EVM. It was, apply best practices of high performance computing by essentially like doing the things that you would need to do to pipeline and parallelize the EVM. I'm not saying that's an easy task, but it's definitely a possible task. So,
got you. And you are coming from, I think, Ethereum originally, and then a stint in Solana. Could you share a little bit about like what kind of attracted you to about those chains and about maybe crypto in general?
Yeah. So when I came from Ethereum in the sense that like when I first got into crypto, it was like I was kind of like nerd sniped by Ethereum. Like I heard about Bitcoin, I was like, oh, okay, this is cool, this is novel. And then I started kind of like hearing about Ethereum, looked into it and was like, oh, this is a really cool computer system. And so like got into Ethereum, was kind of like degenerating around a lot on Ethereum, and then was like, yeah, this is too expensive. I'm going poor very quickly. So I started like looking around at that time. Like I was enough into it that I was like, I'm basically pulling a full-time job outside of work. Like I might as well just actually make this my full-time job. Started looking around the blockchain space of where like my expertise could be applied. And coming from like a very low-level embedded hardware systems background, when I came across Solana, it was the first system I looked at, and I was like, oh wow, like I could actually work here. This looks like an embedded system. Like the design decisions they've made are very much like how a low-level hardware engineer would do it. So that's what like initially attracted me to Solana. Was there for about a year, and then Monad came along, and the opportunity to transition to DevRel came along, which I had wanted to do for a while. So hopped over here, and mainly Monad because it allowed me to kind of stay true to the things that I know as far as like on a technical perspective, which is like a low-level hardware optimization. And so what really attracted me to Monad was it's this like really unique middle ground between essentially like an Ethereum environment, but done like the way like an optimization maxi would do it. Right. And so that's like what was very interesting. And I was like, oh, this is cool. Like, Ethereum and the EVM, like, has really big Lindy and like network effects. And no one's really tried to, like essentially like prove out the Solana like architecture thesis on an EVM. And the fact that they were doing that was just like, oh, this is exciting. Like I need to go and actually like do this. So
and
that's what brought me over there.
What's your theory to like, because we're quite a number of years into the EVM and into Ethereum, and yet to my knowledge, a previous similar project doesn't exist. Like what was keeping people away from doing something like Monad previously?
Yeah, I think like just the amount of kernel and hardware devs in the world is just like quite a bit smaller than the amount of like database and web devs. And so I think like when people, want to tackle problems, they usually like tackle it from like their expertise or like, where they see they could add the most value. And like the team at Solana Labs came out of like Qualcomm essentially, like at least Anatoly. And the guys that started Monad, Keone and James, were designing like really high performance trading systems at Jump. And so it's this like low level C, like our whole code base is in C and Rust. My background's in like assembly and C, and it's just like, yeah, like the world of those devs that exist are, I think, like a lot smaller. And you kind of have to have like OS background, like, like hardware background to be able to like build a very fast system, where you care about like how memory is placed and how it's accessed and kind of like how you would split things up for parallelism. And so I think it's like a hard enough task that like people, like, you need the right team to do it. And so when I saw that there was a team that was actually doing it, it was just very exciting because it's like, oh, why has no one done this before? Right.
Yeah, get you. And I think, I'm excited to have Monad on as one of, well, actually, it is the first non-Solana project. And I think that there's some, they talk a lot about Ethereum aligned values. And I feel like in a sense, there's some Solana aligned values in Monad and in other high performance blockchains. You mentioned that there's parallelization that you guys are working on, which will feel familiar to people who use Solana often. Can you speak a little bit about, like, I don't know if shared values is the right idea, but like that kind of shared mentality or shared mindset?
Yeah, I think we occupy like a very privileged space in the sense that like we're doing something like Ethereum really needs to be done. And yet we're doing it with a design methodology somewhat similar to how Solana was constructed. And so by giving Ethereum like a really nice execution layer, we're also like proving that the Solana's design methodology is viable and good. Right. And so we're in this like really privileged space where from a Solana side, you're like, oh, look, an EVM team is like taking our same approach. And from the EVM side, you get to be like, oh, we actually need like a really good performant, like, EVM layer. And so this is great,
Yeah.
and it's nice. It's nice.
It's like I don't know what like a growth mindset is. Like, you want to have as many people trying different experiments as possible and seeing what works. And I mean, Solana is a good example itself, like it was a very different example to the EVM and to Ethereum. And I recall like a year and a half ago when I was first getting into Solana, it was almost like a laughing stock in many ETH circles. Like, how ridiculous, the expensive nodes.
Oh,
like,
I remember.
Yeah, you remember. And now in the last week we're recording, we've had the good visa, the exciting visa news. We've had, Make a Die considering forking the SVM, and like clearly recognizing the quality of the technology, which is really exciting. I just want to make sure we like double click on Monad enough that people have a sense of it. So could you speak a little bit about like the validator requirements? Like, are there any other elements that you consider sort of really sort of selling points or unique propositions for Monad?
Yeah, so I can go through like kind of the main innovations, and then also I'll hit on the validator requirements. Like to start with, I'll just do the validator requirements. It's somewhere around, or actually I think it is, like our testnet spec is 8 core CPU, 3.1 gigahertz per core, and like 32 gigabytes of RAM. So it's a good machine. It's not like a server side machine, right? Like it's like a modern MacBook, right?
Right.
And so like it's somewhere in between, like, it's not a Raspberry Pi, but it's like reasonable, and it's like also not like a server. And so I think that's kind of where we want to occupy this ground of like, it's reasonable to run a node at home. Yes, it's not like, it's definitely like, maybe reasonable on like an American scale, but I think like if you really want to start like a validator business, what really matters is that like it's profitable in the end. and like the capex of like a couple grand in another country, I think is quite reasonable to like start a business, right?
Yeah.
Or pool with a couple of people. So it's not, like Raspberry Pi level. It's not like, server level. And it's just kind of like a reasonable take, and let's squeeze as much as we can out of that. So how do we do that? We do two things called parallelism and pipelining. So pipelining is the practice of essentially like taking sequential non-dependent pieces and stacking them on separate threads, so that like they're still essentially in order, but the dependencies are unlinked. So in a typical like Ethereum, the way it does it is, in a block, if a block's this big, it'll do execution for a little section of it on the leader, and then it'll broadcast that block to everyone. Okay, and that's like part of the consensus. And then everyone will then replay and execute that block and then come to consensus on it, and all in one block time, right? Well, what you realize is like you actually, once you know the ordering of transactions, you don't actually need to execute at the same time. So what you can do is in the same way that Solana does this with proof of history, separating ordering from consensus, you can essentially like come to agreement on the ordering and then execute in parallel. And the way that we do this, it's called pipelining, because the stages are sequential. Like you first have to come to ordering before you can execute, but you can do them in parallel because you can just be one block behind on the execution part. So when the system starts up, right, yeah, it has to do a round of consensus and then it has to do a round of execution. But then from that point on, you can have consensus executing on block N and execution on block N minus one, and they can both be running at the same time. And so you're only ever like one block behind in that scenario. And essentially by like taking the same concept and applying it wherever we can. So even with the database reads, we're pipelining between basically IO and compute. Like we can do a lot of things at the same time on different threads and like get around a lot of the bottlenecks of the EVM that way. Then on the execution side, like real parallelism that we're doing there is the process of like, you can take a bunch of transactions that are committed in order like this, right? And essentially like run them in parallel, look at their outputs and see if any of the outputs of the transactions touch the input of another transaction. And if it did, then you re-execute that one. So this process is called STM. It's actually like, I think Aptos calls it block STM, but like the actual like base concept has been around in computer science for a while. And what it means is that like you just optimistically execute everything in parallel. And from the information you get out of that, you can build a sequential chain where you never have to execute any transaction more than once. Like you're always making forward progress. And that's essentially like how we parallelize things.
Got you. Okay. Yeah, I mean, it sounds very cool. When are you planning to go live?
Testnet is Q1. So we're a little bit of an early project to be on podcast, but it's definitely fun that people have like kind of attached to the idea and like gotten so excited about it. So we're really grateful to have the opportunity to like come out and like explain what we're building. So
yeah, I mean, I heard about it already, I guess a couple months ago, and I guess it was just that like supercharging the EVM using similar concepts to it's a natural click. I think especially on Solana, if you're used to Solana, it just clicks immediately when you hear like, oh, EVM, but with parallel transactions and much faster and etc. And do you guys have a sense of how much, how many, like what the throughput would look like? And also, is it too early to already talk about like how much transaction fees cost?
It's kind of, we can go over what we know. So our testnet goal is 10,000 TPS. That's not like the most complicated DeFi transactions. It's like, the base layer is what you measure based on like transactions, like simple transfers, right?
Yeah.
So our testnet's aiming for 10,000 TPS transfers. That is not actually the theoretical limit of bandwidth, so we're pretty sure we can hit it. That is the purpose of testnet, right? Is to prove that thesis out. As far as what was the other part of the question?
If you can already have any sort of estimate on how much like fees will cost.
Yeah. So by essentially like decoupling execution from consensus, we have a lot more block time to allocate toward like executing things. And that execution complexity is priced in something called gas on Ethereum. It's actually compute units on Solana. It's the same concept, right? But essentially, if you have more compute units, more supply, you don't have to actually change the gas model all that much to like really lower the gas fees. And because we've essentially like taken the entire block time that was previously split up between execution and consensus, and now are running like the entire block time over consensus on a separate, or over execution on a separate thread than consensus, there's just like a lot more that we can fit into a block. And therefore we're like expanding the supply by like magnitudes. So the gas fees are going to be like quite low.
And how, like Solana targets, I think 0.4 seconds on the slot times. Is there a expectation for what Monad is going to target?
Yeah, so we're targeting 1 second block times.
Okay.
Yeah, and
so you have
and a 100 gigabit internet connection. So
okay.
yeah,
Solana
that's
was one,
kind of
one...
like the real bottleneck is like how much bandwidth you have, and 100 gigabits like pretty standard good internet. Like,
am I right in thinking that's about 1/10 of Solana?
Yes, I think so. Yeah.
Yeah. Okay.
I think like if you can get a 10, I think it's 1 gigabit.
I think
connection.
so too.
Yeah.
I've seen Tolly saying that he has that at his house, which I think is pretty rare, to be honest.
Yeah. Yeah. So 100 megabyte or megabits like down per second is pretty reasonable. Like I work off Starlink a lot of times, and that's like how much I get.
Yeah. And I'm curious, we've spoken a bit about like Solana culture alignment, and that there is sort of a immediate click. How has the reception been on the EVM side or the Ethereum side per se?
Yeah, I think it's like quite actually very friendly. They're like really excited about having the option to have like a optimized EVM. I don't think it's really been an option for them before, right? And so we're giving this like scaling solution in a different way than like L2s or any of these other solutions are doing. And like that's actually just exciting, right? And so I think on the Ethereum side, they're just like, oh, nice, like more options for scaling, right?
Yeah.
We are our own L1, and that's mainly because we want to prove out how fast like an EVM could be, and we believe that the bridging, like trustless bridging technology with ZK is going to get to a point where it's not really going to matter if you're an L1 or an L2. And so like we just want to prove that like we can make the EVM and we can make it incredibly fast. And then if the rest of the Ethereum ecosystem wants to adopt some of our, technology, like we're all for it.
Got you. Yeah, that makes a lot of sense. How would you like? So obviously you're using the EVM. There's more similarities, I guess, in the speed and the focus on performance with Solana. How would you like compare, because you spent 1 year on the Solana side, how would you compare I guess without going too technical, like how would you compare and contrast between Solana and Monad?
From like it's more of a comparison between EVM and SVM, right? So like there's like a good case to be made that there's more Rust devs in the world, coming from the Solana side. But like the reality of the world today is that there's far more EVM smart contract developers.
Yeah.
And so another real benefit of being EVM is like we're doing like the, best practices for an optimized system, but there's a lot of smart people in the EVM doing very cutting edge research, and like a lot of the applied cryptography and stuff is done in reference to an EVM system. And so we also have this like secondary benefit of being able to like leverage and grow like from any of that EVM research, right? Just being EVM compatible. So a lot of like the ZK stuff that's like cutting edge, like assumes that your like essentially operating system of the blockchain is an EVM. And so there's that benefit, plus like there's just actually more EVM like smart contract devs. And like maybe that'll change over time. But from like a go-to-market strategy, it makes like a lot of sense. especially if like there are levels of scale where if it doesn't affect the UX, like other things start to matter more, right? If you have two chains that are running at 10,000 and 20,000 TPS respectively, like you're not going to notice it on UX. You're only going to notice it on capacity. And Ethereum is doing like a lot of work on extending capacity via L2s. And so again, like if our base layer gets, saturated, there's always the option of essentially leveraging all the research that's been done on L2s and like porting that over. Right. And so that's really the benefit of the EVM is like if we make this thing as fast and as optimized as possible, we can then like use everything else that's going on in the EVM to like scale beyond that. And we believe we can get to the point where the UX difference is not going to matter. It's going to be a capacity difference, right? At the end of the day.
Yeah, got you. Do you think we're getting close to that, to saturating those kind of numbers?
No, not even somewhat close. Yeah.
Yeah.
That's the problem, right? Like even on Solana, like with 4,000 TPS, I think at max you see like 500 of actual like user transactions, you know, and that's demand based. It's not capacity based, but like at 10K, you're what? 20 times more than that? Like if we had 20 times more users than everyone on Solana on a blockchain right now, like you would be like, wow, there's a lot of people right now using blockchains. And so like, I think like we're not even close to there yet. And when we do get there, like, we could always have like multiple monads or start doing L2 scaling or stuff, right?
Yeah, to some degree, it feels to me like the most important area to be working right now is in consumer applications. I mean, of course, in very high performant L1s, because high performant L1s have allowed us to be in the situation where we can start to focus on consumer applications. But it really feels to me like that's kind of the tip of the spear at this point. We need to get users using the apps and really truly believing that like that's better than anything that's available to them otherwise, not just because it's Solana or Ethereum or like it's crypto, like it should just be a better application, full stop. So I'm really hoping we get there in the next couple of years.
Yeah, I think like that's where Monad and honestly Ethereum as well as Solana align very much at this point, is we're all just kind of looking around and going like, we need real consumer apps. And like if Monad is maximally successful, we will be the execution layer providing that to all EVM devs. Right.
Yeah, 100%.
And like that's how you actually scale people, is you just have to build things that people want to do. Right.
Yeah. Unfortunately, like a lot of the things that people wanted to do so far, I mean, we saw with FriendTech, we saw with what was the like walk to earn, STEPN. They sort of they have a certain curve, and then the curve reverses. So hopefully we can find some more sustainable consumer applications soon. What are some of the drawbacks to optimizing the EVM and supercharging it? Is there like what kind of constraints are you guys working within?
Yeah, I would say it's more constraints, right? Like I think if being Anatoly coming from like a background of like just optimizing the crap out of everything, he probably looked at the blockchain problem and was like, no, I can just like build this from the scratch in the most like ideal optimized way possible, right?
Yeah.
I think the Monad vision is more of like, wait, like there's a lot of really good things and network effects on the EVM, and we can still make something very, very fast and yet be constrained by those constraints. So essentially have backwards compatibility. So it definitely like affects how we have to design things, right? Because like we are bytecode equivalent with the EVM, that means like anything, any of the tooling, any of the dApps on a normal EVM, you can go ahead and copy and paste and like essentially like get the scale of Monad. But having that backwards compatibility does put constraints on like what we can do, right? We can do parallelism, we can do optimistic parallel execution. Now, the thing where you have state and data separate and you do that analysis up front, like is only possible on the SVM because state and data are separate, right? And so really the best we can do and maintain backwards compatibility is this optimistic parallel execution. But what you realize when you start doing analysis on this system is it's usually an IO bound problem, not like a compute bound problem. So when you've already executed a transaction, you have to reschedule it. If everything that transaction relies on is already in memory and ready to go, it's actually like a very small performance hit to just re-execute it. Like the thing that takes the most time in most of these systems is being like, oh, I need to go fetch this account from disk, pull it into RAM and all that. And you've already done that by the time you've executed it once, right? And so it's not that much of a performance hit to have to do like one extra execution.
So you're
these
talking
are kind
about
of the constraints we have to work around. Yeah, but go ahead.
So you're talking about when you're pipelining and like there is a dependency, and then you need to rerun that transaction or that request in the next. Is it inside the next block?
No, so this is all done in one block. So every transaction in a block would be loaded in what we call executors, and each executor is like its own EVM. And they run the transactions all in parallel. And then they essentially commit them in the order that the block says they should be committed in. And as it's stepping through that order, it's checking, did the output of one affect the input of the next one? And if it didn't, go ahead, commit it in that order. If it did, then you need to reschedule the one at the head of the tip. But in doing that, you already have all of its resources here because you did it when you executed it the first time. And so in that sense, you can do it very, very quickly the second time.
I want to make sure that we're sort of keeping it accessible for like non-technical people. And I mean, I'm non-technical myself, so trying to keep up here. But in Solana, as I understand it, you kind of declare like everything at the outset, and then like if there's sort of crossing wires, we can call or something, then it doesn't execute, or it affects the execution. Whereas here, you're saying like you're executing on the fly, and then like if there's a cross wires, we'll say again, then you kind of re-execute it in like a second step. In a second step,
because
but
Solana
in the same block.
forces you to tell the VM what your dependencies are immediately. Yeah. Now we support something called access lists in our version of the EVM. It's just not like a lot of EVM devs don't actually use them, right? And so we can't like force everyone who's in EVM to do it. Now, if you do it, like we can be smarter about our scheduling. But for the moment, right, the base assumption is you're not doing that. And in the way that the EVM works, because state and data aren't separate, there is like you have to actually execute it to see what the dependencies are. So that's kind of the trade-off there. But it actually like it actually like doesn't prevent a lot of things from being possible. It kind of just like changes the ergonomicness of it, right? So you can do local fee markets, but like in the SVM, because you know your dependencies up front, like it'll tell you what it charges you before you submit the transaction, because it can like kind of look at how many other things access those accounts. In an EVM like system, if you were to do this, and this is just theoretical, this is not going to be live day one, but we've definitely been like thinking about how this would be possible, is you kind of have to do that analysis at the end of the block. So when you do all this parallel execution, then you have all that like state and data contention in front of you, and you can intelligently charge for it at the end of the block. So what that looks like from a user perspective is in Solana, you may be like prompted like a very accurate price up front. In this system, you might actually need to like overpay gas up front, and then like when the transaction actually makes it to the block and you see it on the blockchain, you would just get like a bunch of your gas back,
like a gas refund.
Yeah, essentially. I mean, you wouldn't really be spending it. Essentially, it's because up front we don't know. You're just saying like I offer this much, but like we're not going to need that much, you know.
I guess you.
And I don't know if that's the form it's going to take. I think there are things we can do to make that more ergonomic for devs, and we're kind of tinkering around with what's possible there.
Got you. Okay. And just to go back a little bit, you mentioned that it's EVM like bytecode compatible. So just to make it like really drive that home, it means that if you had an EVM app on, say, Arbitrum or somewhere, you could very, very, very easily, with no changes, be deploying it on Monad, right?
Yes. Yeah. And nice. You know what really excites me about that is not the copy and paste, but the landscape that opens, right? Because I think every ecosystem that we've seen to date, at least that I'm familiar with, which is mainly Ethereum and Solana, like there's actually limits to composability, as much as like we want to say that there's not. Like in Ethereum, it's gas. You know, you just like can't call that many contracts, or it gets very expensive. In Solana, like there's a hard cap of 3 CPI depth, right? And that's just because of stack sizes and stuff. But
Mm.
on Monad, because we're an EVM and we have like optimized gas from essentially like expanding the supply of compute available to the execution layer, you can actually compose like a lot more. So what I'm really excited about is seeing all that stuff from the EVM, sure, copy and paste, but then what you can build on top of it, right? It's like all of a sudden this design landscape of composability that I think was one of the original value props of blockchains is like opens up for real. And so I'm pretty excited about that.
That reminds me a little bit of first using Solana and experiencing that like almost instantaneous swap where it had a click moment for me. I was like, okay, I could really imagine playing a video game and doing transactions as I'm playing. I could really imagine like doing a social app and actually having that be part of, you know, the normal app behavior, not just for like financial payments, and sort of seeing that product landscape open up. And we've seen that come to some degree into fruition with very nice applications like Code Wallet, for example, which I'm a big fan of. So yeah, that's really cool to hear. I won't put you on the spot and ask you for some like predictions on what kind of apps can be built with this new composability, because I guess it's just an organic thing that will come out once you've kind of copy and pasted the core primitives. But that's, yeah, very exciting angle. Maybe just like to make sure that it's super obvious for the listener, could you like in a very sort of ELI5 explain like specifically why that's a possibility on Monad and versus other L1s?
Composability, essentially.
Yeah, why you have that extra sort of depth.
Just gas, honestly. So the EVM already kind of supports like not unlimited, but practically unlimited composability, right? And like the reason it's been stopped today is just because like the gas costs of like actually re-executing are, you know, like very expensive of like diving through like a bunch of contracts.
Yeah, got you.
And then like with the L2 thing, it's like you can compose within an L2, but like you know what I mean? Like cross L2 gets weird. There's bridging times. There's stuff like that, and that's where, you know, we kind of like cross between like EVM and SVM land, and are just like, well, we actually really like are excited about this, you know, like composable landscape, and yeah.
Nice. I mean, I suppose it's all going to get more blurry in the future as we move to this uncertain future where L1s are L2s and L2s are L1s, and they're
And
all
L2s
interconnected.
aren't real.
And yeah, L2s aren't real. They're just multi-sigs. So
that's John Sharp there.
Yeah,
Throwing
exactly.
bomb into the mix.
Exactly. I can add that article to the show notes, but it's a doozy to go through. Kind of what's that like? You know, the GIF where the guy's head is exploding. That was my experience of reading that article.
Everyone's like, "Oh my god, are R2s real anymore?" It's like the definitions of these things they're going to evolve a lot, but like very tangibly, I think like you can't be bridging like in like in like a highly activity app, right? And so if you're a game, like doing cross like roll up stuff it's gonna have to be hidden between like, you know, when you're playing the game, you're gonna want to be on a single roll up or like a single shared piece of state. And the more stuff you have on that, the more interested you can make the game. But when you start getting into like cross roll up stuff, it needs to be hidden between like, you know, in the game, it might be like, okay, pack up your backpack. Now you're going to this other area. And like, you know, the UX UI of that could take 2 or 3 seconds. And in the background, it could be bridging. Right. But
And
you can't
there's also
do
the
that
risk
for every app. Like,
yeah, there's also the risk of bridging itself. You know, I mean, until now, more or less, there's some risk involved versus like a native asset. And then we hear like, I think it was Vance was talking about the future with like 1,000 different chains, and it's like, yeah, how do you compose across them? But I mean, this is a problem for different people than you or I, because we're focused on these high performant composable L1s. So as we move towards like wrapping up here, I'd like to go through some sort of quick fire answers and get some takes from you. as we said before, like you're representing yourself and not Monad. So feel free to go wild with your answers and not pull. be honest. Okay, so first one is what is the most overrated blockchain tech in your eyes?
So I'm gonna say layer twos, but like the reality is like if blockchains are maximally successful, you're gonna need both. But like today, right now, like I think we can do a lot more on the L1.
Yeah, get you. I would probably say app chains, to be honest, at this point. But
actually, like so the Maker DAO throws a weird wrench thing into that. Right?
Indeed. Yeah, it does.
Because like I think if you're really an app at like massive scale, app chains make a lot of sense, you know?
Yeah.
And as like the composable L1, it makes a lot of sense for like tinkering around and stuff. But like if you're Facebook and you hit, you know, almost 1 billion users, like even one Solana might saturate, right? And at that point, you're like, okay, maybe I do want an app chain. And that's where I get a little confused with L2s because like as an app of that size, I don't know how many of them would be comfortable with like essentially outsourcing a lot of their other like infrastructure needs to other startups and other teams. Right.
Yeah.
I think like if you're a startup with that much size and you care about your users, like really you want to own all your in-house infrastructure. And that's where an app chain really comes in.
Yeah, true. It was also, I thought that news was supposed to be quick fire answers, but I want to actually double click on this just for a second.
Yeah. This is an interesting one.
I thought it was also like I was always really excited about Cosmos, Solana, and Ethereum because they had kind of slightly divergent visions, and it does feel like those visions are actually starting to converge more than diverge. But it was a little surprising even for myself to see that Cosmos was kind of left out in the cold on this one, and you know Rune instead chose to highlight the tech from Solana because it feels to me like we saw DYDX a year and a half ago or so. I'm not sure exactly how long it was. They migrated to Cosmos, but they were not like super Cosmos aligned. And so you would have kind of like it's a natural fit you would think for Cosmos. Like that was kind of the vision that they've been building, this idea of like app, you know, a chain of app chains. And yet apparently it wasn't a good fit, and the SVM was a more exciting prospect, which I think was a surprise and is honestly, a bit of a negative story for Cosmos. I think in terms of their vision.
Yeah, I guess like I can't speak for him. I don't know exactly what the motivations were, but like I think local fee markets and parallelism are genuinely useful things to have like on a blockchain. And so yeah, I don't know. I like if I'm Maker DAO and I'm really trying to hit mass scale, like maybe that came into the calculus, right?
Yeah. And just with parallelism, I think it's so often really brushed over. But if you remember, if you're maybe 30 plus, and you remember using a Windows desktop PC back in the day, and you know when it would freeze and then it would slowly execute across the programs, across the steps you did, that's essentially what you've got when you're executing in like a linear fashion. And I recall using Phantom a while ago, and it was so obviously like a worse user experience to see like my transactions slowly going one by one. And so, yeah, really can't be understated, I think, that the positives of parallelizing.
I mean, that was a great description, by the way, of like what happens in like a single threaded environment. But like another, just like to put a double click on it, is like you can't go buy a single threaded CPU today. Like they don't exist, you know. And so like normally you have at least 4 cores or at least 2 nowadays. So it's like, why don't we use them?
Yeah, 100%. And speak just lastly on that convergence again. You know, from what I've been reading, I don't follow it too closely, but it seems like the direction that Ethereum is heading is also going to be moving in, higher like requirements for block building validators. So again, in the end, the trilemma, we chose different areas and optimized for different things. But in the end, it seems like on the journey towards getting these very highly performant consumer ready apps, there's some convergence taking place.
It's like you can't cheat physics. Like at the end of the day, like, you can't, right? And I think like where it lands you is like, okay, the thing that matters is the verifiability, right? And so if the verifiers are lightweight and the builders are heavier weight, that's essentially become the compromise nowadays. And I think all blockchains are realizing this. You know, Cosmos with Celestia doing light clients and having heavy block builders, Ethereum with Vitalik's endgame roadmap thing, and now Solana building, you know, its own light clients as well as Firedancer, right? And you start to realize like you can't beat physics. Like you have to have a beefy machine somewhere in the system. And then like as long as users can verify that trustlessly and cheaply, that's a pretty good compromise. Like,
I suppose if you're coming to crypto, maybe a traditional Bitcoiner might say like, you know, it should be able to, as long as there's internet, it should be able to run regardless of anything basically. And I should be able to run a node and etc. I mean, Bitcoin also uses miners, so I don't know where the argument really ends up, but there is some compromise being made, and many of us are perfectly happy to have a distributed, 3,000 different validators, and we feel comfortable that like that is a good enough sort of security and censorship resistance that we're happy to make that compromise to have actually usable applications. So
yeah, I think Bitcoin is probably the outlier there. You know, they're very much, I want to be able to sync my node from Genesis, have all the, state there. And while that's actually like pretty good for payments and like, store value, like if you just want to build like expressive real apps, like there's a reason the internet didn't stop there.
Yeah, right. So true. Okay, that was a detour, but let's go back. So next I'm going to get your prediction on what is like the next big crypto trend.
I want to say social. It feels like there's a lot of apps that have gotten really close recently. You know, there's like Solarplex on Solana, Friendtech on Ethereum, and just like even NFTs could almost be seen as like, like the inklings of social, right? Like taking off. And so it just feels like there's a lot of this like zeitgeist energy, like really chasing down social. And I think like we'll get there.
I think so too. And brief detour again, but I always felt that this season of NFTs or this experience with NFTs was a bit like the ICO period for the tokens. Like there's no real proper use cases, but like it's a cool new, new crypto sort of invention or direction. And like it kind of feels like an object in programming to me, like where you can add more details to the, to the token and limitless possibilities, but not like I wouldn't say many real good applications have actually been found yet. But as we all know, after the ICO period, then like Compound and Aave and Uniswap were all built, and then we really discovered a great application for tokens. So hopefully there's some builders building new applications for NFTs that will really push things forward in this NFT
really
bear market.
With that take. Yeah, that's a great take.
Okay. Ethereum, friend or foe?
Definitely friend, because while we're doing like the optimization part, they're doing the research, and we will need it at some point.
Yeah, true. True. That makes sense. And we're so done with that like Ethereum killer thing that they had a few years ago. Like let's leave that in the past. Okay, last one here. What is going to be the next big crypto controversy?
Okay, so I got two, I guess.
Two?
Yeah. One, like Binance seems to be in the hot seat right now. So we'll see what happens with that. Like hopefully not another FTX or something. And then the other one that I think is kind of lurking under the surface that we saw inklings of is Curve. I don't think the risk there has actually gone away.
Do you think it's like a too big to fail kind of situation in a sense?
With Binance or Curve?
Both, actually.
I don't know.
Yeah.
I honestly don't know. DeFi is a little, DeFi is permissionless and automated. So like, it's nothing but code that executes. So I don't know if there's like intervention or I don't follow the situation super closely. All I know is that like the risk is still there. And then with Binance, it's in like meat space. So we'll see. Like,
yeah, we'll see. I don't follow too closely either. And like another one which is perennial is the tether topic. But they're still here. They're doing better than ever. So we'll see with Binance as well. Okay, it's been super fun to chat with you, Kevin, and learn all about Monad and just generally get some, like, I would say pretty nuanced, pretty like reflective takes. So really appreciate you coming on. I'll be keeping an eye on Monad as you guys get closer to launching, and maybe we can do another episode once you guys go live to chat about the Monad token that may be coming. I don't know. So
No
yeah, thanks for
comment.
coming on, Kevin. Of course
We'll
not.
see you, man. It was good. Peace out.
Thank you.